last day, if you remember, we started to look, right? We started to look at converting a trig like this, a cos theta plus b sine theta, into the form r sine theta plus alpha. And we also took a look at something called general solution. So we learned to find the general solution for sine, for cos, and for tan. That's how we stopped last day, right? Huh? What's that? It don't matter, it's commutative because it's like saying b sine theta plus a cos theta. So it'll work. It'll work when it's the plus sign, right? Right. So yeah. So we looked at converting them into this form. I showed you how to find r and how to find alpha, right? We also said that the maximum value is r and the minimum value is minus r. That's okay. So that's what we did last week. We did questions, and I showed you. I told you today we're going to try the past paper version of it. All right. So let's take a look at the past paper version of it. We'll talk it through together, and then we'll start it, right? All right, so let's say they gave you, all right, let me put out 2 theta. It doesn't change anything. Huh? I'm going to put it there as well. All right, just give me 1 second and I'll put up 2030. Anybody have that soft copy, 2013? 2013? They have it? No? All right, so what just 2013 here? It might be up, oh, wait, it's upside down. Let me just flip it around. All right, so watch this here. They gave us f of theta, and they gave us that version of it, and they told us what form to put it in, right? You'll recognize plenty of the recent years, they're telling us what form to put it in, right? After you put it in the form, they want the maximum value of that. You should have an idea. And then they want the minimum value of this. Not too difficult. Try it, let me see. Right, so look back at how to find R and how to find alpha, and then see if we could answer part A and B. That was 13.
I was influenced.
Any part hard? Huh? You finish here already? Think about behind. I know I didn't show you, but think about it. Hmm? Think about how you can get a value for that. How you can get a value for that. All right, let's see what you got now. So f of theta is equal to 3 sine theta, that, and they told you the form, right? So it means that r is the square root of 3 squared plus 4 squared, which is 5, right? When you compare 3 cos theta minus 4 sine theta, when you compare it to r cos theta cos alpha, when you compare it to that, you'll end up with r cos alpha being equal to 3. So you could easily find alpha. Alpha will be cos inverse 3 over 5. All right, so your final answer is r cos theta plus, how much you all got for 3 and 5? 0.927. Nice. So that is your f of theta. Right? Do get confused in some of the years if you see a 2 theta here and a 2 theta here, right? Same thing you're doing, right? So what's the maximum value? The max value is 5, right? I know they didn't ask, but the minimum value is -5. There's no other value, right? 5 or -5 at the range, right? How do we find the minimum value? Well, what we could do is we could take 5, see what we get, and put in -5 and see what you get, which is smaller. That's it. So what's the minimum value of this? 130. Right? Just put both of them. You have to, sometimes you have to put both of them just to make sure. So the answer, how it could be 1. Right? The minimum value is 130. Sarah, you okay with that? Yeah, working in radians. Watch here. See how they put pi on 2? Means you're working in radians. Okay, let's try one more like this before I give you some more rules, right? You guys writing? Finish? Okay. Let's try one more like this. This is 26. Close the book already. This is 26, 70. One of them. So we see this is the easiest math that you can get, right? Let's take your time with the smallest non-negative angle part. Anybody confused online? values, right? One minute again, then we start to work it out. Be careful with the last part, right? The smallest. So instead of asking for the max value, they ask for the smallest angle that will give you the max value, right? Take your time and solve the theta. Give me a minute again. And I'll correct it, and then we do the last set of angles. You should get the maximum value at this part, first part. All right, so let's see how it looks now. So first thing first, they told us that f of theta is equal to sine theta plus cos theta. So we need to get it in the form, right? We want to get it in the form r sine theta plus alpha. So the first thing we need to get is r. We know r is 1 squared plus 1 squared, which is the square root of 2 in this case. And then we're going to take sine theta plus cos theta and make it equal to the expansion of this, which is 5 sine theta cos alpha plus r sine alpha cos theta. When we compare, we'll observe that r cos alpha is equal to 1. So it means that alpha is cos inverse 1 over root 2. That's a standard value. So we should recognize that alpha is equal to pi on 4. Yeah, pi on 4. So therefore, f of theta is really r, which is root 2 sine theta plus pi on 4. Right? That's the answer for part 1. In part 2 now, what they asked for, they asked you to find the maximum value of f. So the maximum value of f is positive r, which is root 2. You okay with that? Right, now here's what. They want the smallest non-negative value of theta, which will make this happen. So they basically want us to solve for theta. So all we have to do is to solve root 2 sine theta plus pi on 4 is equal to root 2. Of course, it's much easier than that. Huh? Anybody could tell me when sine theta is positive? Sorry, when sine theta is maximum? When theta is what? Well, when sine theta is 1, it's maximum, right? That occurs when theta is what value? Pi on 2? Sine, right? So you can easily do it like that. But in case you're not seeing that, carry across the root 2, that will cancel. You'll get sine theta plus pi on 4 is 1. Carry across the sine. Carry across the sine. And you'll get sine inverse 1. Sine inverse 1 is pi on 2. So you'll get theta. The one is smallest, right? So it's pi on 2. And then you find the value the next cycle. But the one is smallest. So theta will be pi on 2 minus pi on 4. And we got the answer to be pi on 4. Sure. You're not seeing that. The part underneath there is pi on 4. That's the answer, pi on 4. But if you want, you don't have to do all that. Huh? Watch this, we're writing here in blue. Remember, for sine theta, its maximum value is 1, right? And the maximum value for theta will be pi on 2. So it means that this here is maximum when this is equal to pi on 2. Right? So you don't really have to go through all of that later on, but it's a good habit to follow. A good thing to practice is to do this here. Okay? So that's the answer there. Pi on 4. The part that's missing there is pi on 4. Yeah.
I didn't know cos inverse and the or the sine inverse.
No matter, you choose anyone.
All right.
You choose anyone. Everybody okay with that? So you find a general solution for n is 0. Right? Okay, so that is your that's the first part of it. The last set of identities that we need to learn are called the factor formulas. All right? So the last thing that we need to learn. Any questions online, by the way? Samira, are you okay with us? Kalia, are you okay? Okay. So the last thing that we need to do, technically the last thing in trigs, right? Technically, this is the last new thing that you will learn in trigs. What I will do for you after, I will summarize and show you the little bit of things that you really have to learn in trigs. Most of the trigs come from Form 5, really. Most identities come from there. Okay? But the last set of formulas that we need to learn are the factor formulae. Right? Factor formulae is where we end up with formulas that will give us answers for sine A plus and minus sine B, cos A plus and minus cos B. Right? We have to learn those formulas, right? I don't think these is common sheets, so you have to learn these off, right? Yeah. So you see, normally we had sine A plus B, right? Which is sine A cos B, so on and so on, right? But some people just expand this wrong and say this, right? These two are not the same. So technically, we don't have a formula for this as yet, okay? Do not expand and get at it. That's wrong, right? We are going to develop a formula. I'll do one for you and then I'll give you the others, right? You don't have to learn the proof, right? You don't have to learn the proof. I'm just showing you where it came from. All right, so watch here. All you have to do is learn all the rules. So let's recall a few things, right? Let's say we have sine x plus y. Sine x plus y is sine x cos y plus sine y cos x. And sine x minus y is equal to sine x cos y minus sine y cos x. All okay with that? Those things we know already, right? Suppose we want to add these two now. Suppose we want to add sine x plus y and sine x minus y. When you add this, you will end up with 2 sine x cos y. When you add this, you'll get 0, right? Do right, Shivi. So try and pay attention, see if it's making sense. All right? I'm not taking it off, so you will get time to write it. You'll follow how I got sine x plus y plus sine x minus y. I just add this. I just add this and this. Add those two. All okay with that? Yeah? All right. Next step. Everybody okay with that? Right. So here we could do. Remember, I want to get a formula for sine A plus B. So if I let A equal to x plus y and B equal to x minus y, right? Then watch this here, right? I'm doing it right here. Suppose I add A and B. I'll get 2x, and watch it good. See that? If I add A and B, the y's will cancel, and I'll get 2x. So it means that x is equal to A plus B all over 2. Are you okay with that? Suppose I say A minus B. What will I get? 2y. And I could say that y is A minus B on 2. Have I seen that? Aaron? Say that? Sarah? Sure. All right, so let's make a substitution now. Let's substitute for A here. Let's substitute for B here. Let's substitute for X here. Let's substitute for Y here. Yeah. Two cos y. How you get that? That's a product, yeah? All right. So when we make a substitution, we're going to get a new formula. We're going to get sine A plus sine B is equal to 2 sine, I'm going to replace x. X is A plus B on 2 cos y, A minus B on 2. That's it. You don't really have to learn the proof, but you have to learn those new identities, sine A plus sine B. Okay? If you had a guess, what would be sine A minus sine B? Take a look at it close. It's similar. But what do you think might change if it were a minus instead? Watch it good. All you have to focus on is here. What you'll get there. What you get? If you subtract them instead, this will cancel, and correct? If you subtract in the middle here instead, these two will cancel, and you'll be left with 2 sine y cos x. So your overall formula will now look like this. your overall formula will now look like 2 sine A minus B on 2 cos A plus B on 2. Right? So just switch around where X and Y is. All right, copy it down. Copy it down and let me give you cos A plus B and thing after. Finish? Finish? All right. Take the rules for cos one time. You prove them the same way, right? Take the rules cos one time, right? Cos A plus cos B, and take the rules for cos A minus cos B. Notice cos A minus B has a negative sign in front, right? Okay, so those are your rules. Let's take a quick example. Suppose I said cos 3x plus cos 2x. Are we doing that? This is the A, this is the B. And that's it. Plug it in the formula with the cos A plus B and you're done. So that'll be cos 3x plus 2x all over 2 sine, cos 3x minus 2x over 2. So you're ending up with 2 cos 5x on 2 cos x on 2. Right? Please don't try and factor out the half one thing. Huh? You can't do that for these functions, right? Suppose I had a product something like this now. Right? Suppose I had sine 9x, sine 3x. Any idea how to express it as a sum of trigs? Yep, sorry. Sine 3x. How you get it? So why to write it in a form like this, huh? A sum of trigs. How you do something like that? Any ideas? So what we'll have to do is check and see which of the rules have sine and sine, right? The only rule that have sine and sine is cos A minus cos B. You see that? So we're going to have to find a way to compare it, right? So here we have we could compare this to minus 2 sine A plus B over 2 sine A plus B over 2. Right? We can kind of compare it to that. So therefore, this here has to be equal to this, and this here has to be equal to this. Right? And yeah, that's how we could figure it out. Think about it. How we could figure that out. And I'll give you a small identity. the whole set here. Right, so we just comparing, right? So think about it, a plus b over 2. All right, hold on, I'm gonna go to a new page. So sine 9x, sine 3x, right? I want to write it as a sum of trigs. Oh, look, I write it back there for you, right? And we're going to compare this to 2 sine a plus b on 2 sine a minus b on 2. The trick is for us to figure out what we could always get rid of this minus 2, right? The trick now is for us to figure out what is a and b. So here's what we know. By comparing, we know that a plus b over 2 is 9x. So it means that a plus b is 18x. And we also know that a minus b on 2 is 3x. So a minus b is 6x. That's okay? If we equate both of them now, sorry, if we add here, let's add both of them, we'll get a plus a is 2a, b minus b is 0, 18x plus 6x is 24x. So it means that a is equal to 12x, right? And it also means that b is equal to 6x. You okay with that? Right? So therefore, we could say that, remember, this is equal to cos A minus cos B. I'm moving across the minus 2, right? So now we could say minus a half cos A, which is 12x, minus cos B, which is 6x. So I compare the A and B. You have to figure out which formula to use, right? Which relationship to use. So I compare this to minus a half cos A plus B, and I equate the 9x with this, and I equate the 3x with this, and then solve for A and B. Right? Don't forget to remove the minus 2, right? So that's how I got minus a half. Right? Remember the original identity is 2 of this, right? Minus 2 of this. So I'll move it here to get minus a half of cos A, cos B. Right? That's how come it's written like this. All right, just try one from my right. Same thing, express as a sum of traits. Right, let me give you a b from here. Sine 8x cos 4x. So you have to go back and figure out which identity will work and then work it out, right? All right, let's see what you end up with here. So there's the last identity after learn. It's the last one. All right. So sine, so what do we know? We know that sine A plus sine B is equal to 2 sine A plus B on 2 cos A minus B on 2. Right? I don't want it 2 here, so I'm moving it on the next side. So I'm rubbing it off, and I will end up with a half here. Okay? So it means that 8x has to be equal to this. A plus B on 2 is 8x. So A plus B is 16x. Right? And then A minus B on 2 is 4x. So it means that A minus B is 8x. So I have equation 1 and I have equation 2. I am going to add them, 1 plus 2. Right? So that will give me 2A is equal to 24x. So I got A to be 12x. Yeah. And therefore B will be 4x. Yeah, 4x. So it means that my final answer will be 1/2 sine A plus, open brackets, 1/2 sine A plus sine B. How you get the fraction market Malia? Everybody okay with that? Yeah. Let's try identity now using this. Let's try an identity using it, and then we will try to solve something using it. Okay. So try this one here. These are not past paper. This is my book I use sometimes, right? Let's see if we could prove cos 3x plus cos x all over sine 3x minus sine x is equal to cot x. Try that, please. What is cot again? Cot is what? Right? Remember what cot is, right? Go ahead. Do your thing. Let's see what you get. take your time, right? These are kind of big expansions, so you want to make sure you space it out and expand it out properly. And trouble? Huh? What's that? But yeah, do I look like I? Excuse. Thanks. Huh? You get? Did you get it, Shubish? Hey, you don't need no form 5. It's the same two identities from today. This boy is getting me mad, boy. 2 lines? No, Christopher said 2 lines. I doubt that's 2 lines. I hope he didn't cancel here, you know. Oh. Right, so if you take the left-hand side, it will be 2 cos 3x plus x over 2 cos 3x minus x over 2 all over 2 sine 3x minus x over 2 this will be plus, right? Cos 3x minus x over 2. Oh yeah, you're really right. Huh? Oh yeah, it's minus, sorry. Sorry then. Here is minus. And here will be the plus, right? Sorry about that. This will cancel with this 2 will cancel with this. And you will get 3x minus x is 2x over 2. 2's will cancel. So you'll get cos x over sine x. Well, yeah, before you go check now, I'm going to show you the SP. Right? I sent to the others, but didn't respond to me. So I would start with you, right? And somebody else. Jenes. Right. That's all right. Yeah. So I'll keep in a group before the one. I spoke to her yesterday. Yeah, Christopher, I'll put you with Selena, one of them again. But I asked them first. Right, I'll try to send you all the samples today. Right, so this is cortex. Are you okay there? Since you're all having so much fun, I'm gonna give you one more. Most of them have that. I'm gonna give Shivish one. Should get this one here. Will you get this one by Shivish? I want to make sure I get this one. Khaled, you okay? Trouble? Let's take one more. Try this last one. You'd have to write back the identity, no? But when we like write identity and then substitute it? No. That was a long time. Well, that was something that I used to look at in GC. Now, okay. Once the identity you're using right and you apply it correctly, you get it. Ain't getting enough time to finish these things the way to write that angle. Ain't got the time. right? If you check in the group, I just sent 2 papers. We could just try the first one, the trig question for tomorrow. When the product come out of. You have to learn the 2 things and just practicing that question. Right, sine 4x minus sine 2x. We're doing the same thing again. That will be 2 sine 4x minus 2x on 2 cos 4x plus 2x on 2. That's okay? Using the rule, right? And the next one will be 2 cos 4x plus 2x on 2 cos 4x minus 2x on 2. Right? Usual thing will happen. This will cancel off. And you'll be left with sine 2x on 2 all over cos 2x on 2. 2's will cancel. And you'll get sine x on cos x is equal to tan x. That's okay? Right. While we're here, I'm going to talk about something, right? Suppose I ask you to solve sine 4x minus sine 2x is equal to, let's make it up something. Let's say a half, right? No. I'll break this tip again. I said it. No more. Right. So sine 4x minus sine 2x. Suppose I ask you to solve something like that, right? I just give you a simplified version, right? We need to be able to break this down, right? So one of the things that we could do to solve something like this and get the angles is to use the identity that we use here. And we would have gotten 2 sine x cos 3x equal to a half. Or you would solve something like this, right? Actually, let's not make it a half. Let's make it 0, right? Because that's what you might actually see. What you could do there. In order for you to solve this, what you could do is, since it's a product equal to 0, what you could say, well, you could say that 2 sine x is 0, solve that. Cos 3x is 0, solve that. Just enough? So in order to solve something like this, what we could do is use the factor formula, get 2 factors, and make it equal to 0. That's okay? You'll see why it's kind of called factor formula. You're getting 2 factors for this trig summation here. You okay with that? Yeah? So if you see something like that, that's the way you will handle it, right? And then solve 2 sine x equal to 0, cos 3x equal to 0 between the given range. All right? That's what I wanted to show you in case you see one like it. All right. So technically, what that did, that kind of brings us to the end of trigs, right? So all the theory behind trigs, you would have done it. It don't mean that you magically get better at trigs. So what we need to do is practice a lot. So tomorrow I want to do that practice, right? We still have coordinate geometry and vectors to do, but we could do that quickly next year. That's not long. All right. So tomorrow I'll send you 2 years. What will be good is if we could start working. I'll give you 2019 and 20 something I sent. Right. So in 2019, I will take your time and try that home for me. Right. The next one I'm going to share here, we will start doing that one now, right? That was 2020. What did I send again? 2022, you said, right? Right. So the first one I sent, I want you to try it. The second one, we are going to start it now. Right? And we're going to do 1 or 2 harder things. If you look through the past papers, you will see something like with triangles. We know the formula for tan A plus B, right? But imagine you have a formula for tan A plus B plus C. How you want to handle that? Right? So I'll show you to handle questions like that, right? So let's start with this 2022 today. Right? This 2022 shows the format of what your exam will look like, right? So to take a look at this. Everything here should be, you should be able to handle it. Right? So you get basic, you get a basic logic and reasoning. You'll get a remainder factor, a logs. Sometimes you'll get PMIs. Then you'll get functions, right? Some indices to solve, some logs, and then alpha, beta, gamma. That's generally the format. Number 1 and 2 is where you try to pick up full marks. But those questions, once you practice, not difficult at all. Then you have the trigs. All right. So we are going to try these trig questions here. All right. So we're going to try these trigs here. Before we start, I want to just do over one of these because I didn't do any like this. Right? You'll remember the triangle method. Like if I give you a sign A and you create a triangle to show where everything is. Okay, I'll do this one for you just to remind you, right? Watch this here. No calculator. Where is my pen? Oh, not because it's for a long way. Yeah, the so-called toward thing here. So I wanted to show you this one because we didn't do any examples like this as a revision. What do I take back off? Take back off this. Try to share it here. And the pen should appear. Nice. Right. So if you remember this, ignore this for now. Pencil now. God. Right. Ignore this one for a little bit. Suppose I told you sine A is equal to a half. Right? How do you find cos A and tan A without going to the calculator? Right? Let's assume A is, let's start with the easier one, acute. Acute means it's here, first quadrant. And we know that sine, cos, and tan positive. Here's sine, here's tan, and here is cos. Okay? So how do we work this up? Well, you need to remember your little triangle. Here's A, right? Here's A, and this is opposite, this is hypotenuse. Opposite is 1, hypotenuse is 2. How do we get adjacent? Should we ship it out to places? You can help me out here. How you will get adjacent? Huh? How you get the adjacent, Shivish? We have hypotenuse and we have opposite. I realize nobody laughing. How was it? Anyway, class finisher, right? 2 squared is equal to 1 squared plus adjacent squared, right? So you use Pythagoras theorem. That's okay? Work it out and you will get adjacent to be root 3. So now that we know adjacent is root 3, we can find cos. Cos is adjacent over hypotenuse, tan is opposite over adjacent. That's okay? And they all carry the same signs. Why? Because A is acute. That's okay? What would have happened now, Adrian? In our example here, they say A is obtuse. Obtuse means first or second quadrant. Second. So it means that cos is what? Negative, and tan is negative. That's okay? So you're doing the same thing. All right? So you're doing the same triangle method. Right? Let's say here's A, opposite is 1, hypotenuse is 3. Right? From the top of your head, we'll work it out in terms of what is opposite now. How much will I get? 2. Well, square root of 8, right? Square root of 8, which is 2 root 3, right? But remember, A is obtuse, right? A is really obtuse. So what does that mean? It means that cosine A will be minus adjacent over hypotenuse, and tan will be minus opposite over adjacent. That's okay? That's basically how you work it out, right? Sine's really important. Everybody okay with that? So just work out what the adjacent is and allocate the appropriate sign, and you're good to go. All right, so let's just do one identity and we do, oh, sorry. Copy down if you need to. Right, so you will try that 2019 for homework, right? If you can do 2022, that'll be good. Practice it. I'll take a look at the way you present your solution or something, and then we will do some of the harder questions in the papers and wrap up tricks. All right, last thing you're doing here from her, taking up this, right? Just do this PMI from up. Sorry, not PMI. Just profanize it. Can't remember if it hard or easy, right? Huh? Oh, yeah. It was hard or?
This is it's tan.
Time.
This tan.
Finish already? All right, one person finished there. Get? See one QED so far. Next one coming in there. The next one coming in there. Okay. Very soon now. Going on soon now. Everything good? Everything good, man. All you guys? Scarlett, no, you didn't get. So sometimes I like to just work with the right hand side a little bit, and then I will go back on the left side and do it, right? So I'm finding the LCM here, cos theta plus 1. Oh, well, that's it. That's all we have. That's all they have to offer, right? But because the denominator looking like that, I've seen a little trick that you might need. You might need to multiply by this. Might. And then you'll get 1 minus cos squared on top, and you'll get cos theta minus this on this. Might. I just seen a little trick that you might need. Huh? So we have, let's we can finish it in 170 seconds. Huh? All right, so left hand side. Tan theta, there is no tan here, so I'm getting it one time. That's sine theta on cos theta, multiply by sine theta on 1, all over 1 minus cos theta. The numerator is now what? The numerator is now sine squared theta, and I'm bringing up this 1 minus cos theta. Look, we get the answer already. See that? Sine squared is 1 minus cos squared all over cos theta by 1 minus cos theta. 1 minus cos squared is 1 minus cos by 1 plus cos. This will cancel with this, and you'll get 1 plus cos theta over cos theta. Right? When you divide it up, that will give you 1 plus 1 over cos theta. That's it. All right, so you had to move the left hand side was straightforward, right? You need to remember these little things earlier. I suspect you already here comfortably. So the problem may have been when you reach here, you forgot about the difference of two squares, right? So you have to remember those little things. All right. So for today, we'll stop there for today. Tomorrow is plenty practice. And yeah, that's it for trigs, right? I'll give you a summary on these little rules. I think I still sent you a summary already.